Dear students, good evening. In today's session, I am going to explain the very first theorem of the chapter, areas of parallelograms and triangles. So let us have a look at the theorem. The theorem says that the statement of the theorem is parallelograms on the same base and between the same parallel lines are always equal in the area. So first of all, the things we need to take care in proving the theorem in geometry is that we need to understand what is given and what is to be proved. So very first thing is which we need to take care of is we always have to start with whatever is given to us. So we'll always write given, then we'll write prove. So it is important from exam point of view, as well as it makes a picture clear to us that what is given and what we need to prove. And then drawing the diagram is very important, which I've already drawn for you. So let me write the given. So given is that ABCD, and as you can see, and EFCD. So A, B, C, D and EFCD are two parallelograms on same base CD and between same parallel lines. So they are between same parallel lines. Parallel lines, which are the parallel lines? The parallel lines are CD and AB. So I'll write AB and CD. Okay. So next I'll write what is to be proved. So I need to prove that area of the parallelogram ABCD is equal to area of the parallelogram EFCD. So I hope the picture is clear to you. So diagram given to prove. Now I will start with the proof of the theorem. So now I'm clear with whatever is given. So I'll tell you the outline of the theorem. The outline of the theorem is we'll consider the triangle ADE. So I'll mark with green. So ADE, we'll consider these two triangles ADE and BFC. We'll try to prove the two triangles congruent. And as we know that congruent triangles are equal in area, so we'll try to manipulate that result to get the final result. So I'm telling you the outline so that you can also think on the same line. So let us try to prove the two triangles ADE and BFC congruent. So I'll give you the solution. So in triangle ADE and triangle BCF, if we notice AD is parallel to BC, so triangle ADE will be equal to angle CBF. So DAE. So angle DAE is equal to angle CBF because they are corresponding angles. Okay, corresponding angles because AD is parallel to BC. So AD parallel to BC. Everything in the reasons have to be written. If the marks are counted for that. And then similarly, we will write AED, angle AED is equal to angle BCF. Again, same reason, corresponding angles. So AED, if I notice, I'll mark with red, AED equal to it is BFC. So it is BFC. So these two angles are congruent, equal because corresponding angles DE parallel to CF. So DE parallel to CF. Okay, and also we have AD equals to BC. Also AD equals to BC because it is given that they are opposite sides of a parallelogram. Now if you notice, is it helping us all the three things? If I notice this is what? AAS. So if I try to prove the two triangles congruent by AAS, and we know that this won't help because AAS is no congruency rule. So we'll try to prove it by some other congruency rule. So since we have two angles of the two triangles, two corresponding angles equal. So what I'll try to do, I'll try to make the third angle equal, AD, E and BCF, and that is very simple by ASP of a triangle. So this is 1, this is 2 and this is 3. So what I can do, I can just say that by 1 and 2 I can quickly write 180 degree minus angle DAE plus angle DEA is equal to 180 degree minus angle CBF plus angle CFB. So this is, we are going on the track of angle sum property. So I'm taking the next page. I hope this is clear to you. So let me quickly take the next page. So that gives me, if you notice that this will give me 180 minus DAE plus DEA will give me ADE, and 180 minus CBF plus CFB will give me the angle BCF. So I am moving on to the new page. So this will be angle A, we can look back, ADE equals BCF. So ADE equals angle BCF. And again, I will repeat again, we have to always mention the reason. So by angle sum property of a triangle. Wherever you are missing out the reason, there is a chances that your marks will be cut. Okay. So now since we will mark it as 4 because we have already marked 1, 2, 3 and 4. Now by, if you see by 1, equation 1, 3 and 4, equation 1 is what, DAE, this one, 3 is this AD equals BC, AD equals, yeah, BC, and the triangles ADE equals BCF. So by equations 1, 3 and 4, so by 1, 3 and 4, what do we have? We have that the two triangles are congruent, and by a valid congruency property, triangles are congruent by ASA. We took a longer route because initially we were getting AAS, which is not a congruency property. So to prove the triangles congruent, by ASA we did all the subtraction and we used ASP property. Okay. So now coming back, we know that areas of congruent triangles are equal. So can I quickly write? Therefore, area of triangle ADE is equal to area of triangle BCF. So reason is areas of congruent triangle are equal. I'm writing the reason just because to make you aware that writing reasons are very, very important in geometry. Okay, now answer doesn't stop, finish here. What we need to prove is, let's look back, we need to prove that the area of two parallelograms are equal, and we have just proved the area of the two triangles are equal. So how will we proceed? What we'll do? We'll move with the common part, that is EBCD. So if we get the hint that if we add the two areas, equal areas on the common quadrilateral, we can get the result. So let's try to do that. So we start with area of parallelogram ABCD. We'll break it up as area of triangle ADE plus area of quadrilateral EBCD. I'll move back just to make you aware. Area of ABCD is equal to ADE plus EBCD. That's very obvious by the image. So if I mark this as 5, so by 5 I can replace area of triangle ADE equal to area of triangle BCF. So by 5 I can replace, so reason by 5. Okay, now area of BCF plus EBCD, let's look back. What is this? Area of BCF plus EBCD, that gives us the second parallelogram EFCD. Okay, that's very easily gives us the second parallelogram EFCD, and we realize that we have reached the result. So hence the result. Okay, that was quite obvious. Okay, so I'll revise the theorem statement. Parallelograms on the same base and between the same parallel lines are always equal in area. So next we'll be doing the questions based on the same theorem. So let us move on to the next question. The very first question based on the theorem. The question says, if E, F, G and H are respectively the midpoints of the sides of the parallelogram ABCD, show that area of EFGH is equal to half of area of ABCD. So in the questions where diagrams are not given, what we do, we have to make the diagram first to understand what we need to prove. So I'll quickly make the diagram. So this is a parallelogram ABCD, and E, F, G, H are given to be the midpoints E, F, G, H. And let us read out the question again. They are respective to the midpoints of the sides of the parallelogram ABCD. We have to prove that EFGH. So quadrilateral EFGH. Nothing is given. It's a parallelogram or whatever. So EFGH quadrilateral. That means we need to join EFGH. So that becomes our construction. Join EFGH. Okay. We need to prove that EFGH is equal to half of area of ABCD. So we will be needing one more construction. So before that, let me tell you, we need to write the given. We need to write to prove, and we need to write if there is a construction, and then we'll proceed with our proof. Okay. So given is ABCD is a parallelogram. And E, F, G, and H are the midpoints of sides of parallelogram, of sides of ABCD. We need to prove that area of EFGH is half of area of ABCD. And construction is we have to join F and H. So we'll be join FH. Okay. So now the proving side, if we notice that AH, what we'll do, we'll try to break it into two parts. And as we have also done the theorem earlier, that areas of triangle and parallelogram on the same base and between the same parallel lines are equal in area. So we'll be using the same result along with the previous theorem that we have done. So what we'll do, we'll consider the parallelogram ABFH. So we notice that AH is equal to BF and AB is equal to HF. Sorry, AH is again parallel. So what we'll do, since AD is parallel to BC, opposite sides of a parallelogram, so and AD is equal to BC. So this implies we can say that half of AD will be equal to half of BC. So this will give us AH will be equal to BF, and also they are being part of the parallel lines. So AH also is parallel to BF. So therefore what we can say, this gives us ABFH is a parallelogram. So the very first thing, ABFH is a parallelogram. Now if we notice triangle HEF, I'll mark it for you, triangle HEF and ABFH are the triangles and parallelogram on the same base HF and between the same parallel lines HF and AB. So that we can use that particular theorem to say that HEF is equal to half of area of ABFH. So therefore, since we can write that since triangle HEF and I'll use the short form for parallelogram ABFH are on same base HF, I'll take the new page, and between same parallel lines so therefore I can use the result that triangle HEF is equal to half of, area of triangle HEF is equal to half of area of parallelogram ABFH. I'll move back again so that you can just have a look and revise. What I've done till now, I've proved area of triangle HEF is equal to half of area of parallelogram ABFH by this particular parallelogram, by this particular theorem. Okay. So similarly, what we can do, similarly we can move to the lower triangle. So HGF and HFCD. We can use the same result for the same pair of triangle and parallelogram. So similarly we can write that let's name it, have a look, HGF is equal to half area of HFCD. So area of HGF is equal to half area of HFCD. And what I'll do now, I'll just quickly add the two statements, and I notice that adding the two statements will give me my desired result. Okay, so my desired result is EFGH. EFGH is broken into two triangles. If I add the two triangles, if I break up into two triangles, I get HEF and HGF, which is in the statement 1 and 2. So I'll quickly add 1 and 2. Adding 1 and 2, I get area of triangle HEF plus area of triangle HGF, half common, area of AB FH plus area of, this is plus sign, HFCD, and that is equal to area of EFGH. So for your reference, let me move back again. HEF plus HGF is EGH is equal to half area of ABFH, and HFCD is area of ABCD, and that gives me the desired result, and hence fruit. Thank you. That was all for today. So I request you to kindly complete the assignment and see you at the same time tomorrow. Good night.